just saw is an Arduino project. We use the Arduino Uno board with a Bluetooth chip integrated with it. We also used a robotic arm that is operated using a servo motor. Both the robotic arm and the car are controlled using a mobile app. We don't use actually any controller, it's just an Android app that you can download. And this project can have lots of applications. It actually could be used for the disabled. They could use the car just using their phone. They can move stuff using this project, or just get themselves stuff. And that's it.
For grabbing objects, we're using a robotic arm controlled by a servo motor. The servo motor is connected to a 6-volt battery, like this, and its ground is connected to the ground, also connected to the ground of the Arduino. So we have a common ground, which is the Arduino with the signal. The signal of the servo motor is connected to the Arduino to 9. The servo motor is controlled by a PWM, a pulse width modulation, which controls the angle of the robotic arm. The angle is controlled in the code by a switch case. The switch case gets its input from the Bluetooth app on the mobile. It can be either controlled. It can be controlled so that it can open to 150 or close to 20 degrees, or through a slider, so it can be we can control the angle even further.
So in our project we are using a Bluetooth module, which is HC05 Bluetooth module. The theory behind this Bluetooth that it has 4 connections. One of them is the TX, which is the transmitter side. The other one is the RX, which is the receiver side. The third one is the ground, and the fourth one is the VCC of the Bluetooth. To have this connection in a successful way, we have to connect the RX of the Bluetooth to the TX of the Arduino, so the receiver is connected to the transmitter, and we have to do it in the opposite way. So the TX of the Bluetooth should be connected to the RX of the Arduino. When we move to the practical connections in this project, we will find the 4 connections of the Bluetooth in this way. The closest one for me is the green, then we have the brownish, then the blue one, and the last one is the orange one. This green connection is the TX of the Bluetooth. It should be connected to the RX of the Arduino. We will verify this. If we find it, we will find it emitting from this way and connect it to pin 11 of the Arduino, which is the RX of the Arduino. And then the second one is the brownish one, which is the RX of the Bluetooth, and if we follow it, we'll find it emitting it from here and connect it to the 10th pin of the Arduino, which is the TX of the Arduino. And then the third one is the blue connection, which is the ground of the Arduino, and to have a common ground we are just connecting it, and if we follow it we'll find it connected to the ground of the Arduino. And the final one, which is the orange connection, we will find it going from there, which is the VCC of the Bluetooth connected to the VCC of the Arduino. So this model makes us have a successful connection.
So for our Swinch project, we use 3 sources of power. First of all, 9-volt battery, a 12-volt LiPo batteries, 3000 mAh. And the third one, 6-volt source of power. We made using connection, a series connection between 4 batteries, AA each. The issue is, why do we need power sources? First of all, we need power sources to operate a servo motor, which moves the robotic arm. Second one is we need to power the Arduino, our microcontroller board. The third one is we need to power the motors, the movement of the car. Fourth one, we need to power the Bluetooth. Why all these sources? Why 3 sources? This is a question you're going to ask. I tell you, the issue is hardware never fails to surprise you. We have 3 sources. Assume we work first with only one source. The issue is, you power the Arduino, the Bluetooth takes in some power from the Arduino, and you power also the motors and the robotic arm with one battery, let's say the LiPo battery. What happened is, out of the blue, you send signal to the Bluetooth module, the Bluetooth receives the signal, sends it to the Arduino sends the signal to the motors, and the car starts moving. Once the car moves, it draws some high current from the battery. What happens is, all works fine, but the Bluetooth restarts. What I tell now is you can figure out the reason, but when you see it for the first time, you just try and try and try. We grabbed a new battery for the Arduino, separate, which is a 9 volt, separately from the 12 volt, which powers the motors. The same issue happened with the robotic arm. The robotic arm, once we powered it using the 6 volt batteries, and we all powered the Arduino using the 9 volt battery, we powered the Bluetooth using the Arduino, we powered the motors using the LiPo battery, and the arm does not move. The Arduino sends its signal, its pulses, relative to its ground, and this sees a 6 volt relative to the battery ground. So we need to unify these grounds, 6 volt ground and the ground of the Arduino, to one ground. So the motor could recognize the pulses relative to the same reference.
Now I'll talk a little bit more about the technical part of the car movement. We got 4 motors that specify the movement and the direction of movement of the car, and the motors are connected to an H-bridge. It's that red chip right here, and the H-bridge is connected to our Arduino Uno board. The H-bridge takes 6 inputs. Enable A enables these 2 motors, enable B enables these 2 motors, and each side of them have actually 2 inputs, so it's a total of 4 inputs. The different combinations of the inputs specify which direction the car moves into. For instance, if we move both sides forwards, the car moves forwards, and if both of them move backwards, the car goes backwards. If we enable this part forwards at this part in the backwards direction, the car rotates. And this implementation in code, we implemented this in Arduino C code, and it is actually really simple. It's just a switch case with all the combinations that specify the direction the car goes into, and that's specified with the Android app. That's it.
Wow.